All right. Along with seeing like an organic chemist, another thing you have to be able to do is speak like an organic chemist. And so you have to learn the nomenclature, right? If you go to Spain, you got to speak Spanish. If you are in a chemistry class, you got to speak chemistry. So let's start off with the simple ones, alkanes. And an alkane is just a hydrocarbon. So just carbon and hydrogen. And in an alkane, we have all single bonds. And so we name this stuff based on how many carbons we have. So one carbon is named methane, right? The ending ane, you see alkane, ane. So methane is just one carbon, so it's just CH4. You explicitly write out CH4. You don't have like a dot or a line or anything. Two carbons is ethane. Again, the ane. And so this can just be drawn as a straight line. Both of these carbons are CH3 carbons. 3 is propane. 4 is butane. So propane, the gas you use in your grill, butane, also used as lighter fluid. 5 is pentane, like a pentagon. And so you should draw 5 carbons, right? 1, 2, 3, 4, 5. 6 is hexane, like a hexagon, 6 sides, 1, 2, 3, 4, 5, 6. 7 is heptane, like a heptagon, 1, 2, 3, 4, 5, 6, 7. 8 is octane. That's what they use for your fuel rating or fuel rating, right? You can buy, 83, 93 octane rating. Octane is 8 carbons, 1, 2, 3, 4, 5, 6, 7, 8. 9 is nonane. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 10 is decane. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you can count them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 carbons long. All the ones in between are CH2s, and the ones on the ends are CH3s. So there are your alkanes. Memorize all of this stuff. You got to be able to name them and draw them. Next up, we have alkenes. So alkenes, there's at least one double bond. So the simplest alkene is ethene. So notice we went from ethane to ethene because now we have an alkene. So if you draw ethene, it's a doubly bound carbon. Next simplest one would be propene. So you see, you just have to memorize the prefix and then the suffix. So one double bond, 3 carbons, right? Remember, this is, and these are sp2 hybridized carbons, and this is an sp3 hybridized carbon. This is a CH3. This over here is simply a CH, and this one right here is a CH2. Be able to identify all of this stuff. Next up, we have butene. But now we actually have some choices. So for example, we could put the double bond on the first carbon. So this is called 1-butene. Right, because we have the double bond on the first carbon. So 1, 2, 3, 4, you see the double bond goes between the first and the second carbon. You always use as low numbers as possible. So another option would be 2-butene. Now our double bond is going to start on the second carbon and go to the third carbon. So in this case, there's 2-butene. In this case, I've drawn the trans isomer, but you could also draw the cis isomer. Next up would be pentene. So we can draw 1-pentene. So the double bond starting on the first carbon. Or we could draw 2-pentene. right? Again, I've written the trans version of this. And then you might be thinking that you can have 3 pentene. So let's take a look at that. Right, so you're thinking maybe 1, 2, 3, 4, 5, right? Starting on the third carbon, so 3 pentene. No, that's actually not correct. In organic chemistry, we must always use as low numbers as possible. So instead of counting from left to right, we could count from right to left. So 1, 2, 3, 4, 5. And so you can see this one is actually 2 pentene. And so I've drawn the trans version there. Of course, I could draw a cis version. Right, so this here would be cis 2-butene. Right, 1, 2, 3, 4, 5. Or pentene, my bad. Pentene, right? All these are pentene, 5 carbons long. And then finally, we have alkynes. So in alkynes, we have at least 1 triple bond. And so the simplest one would be F-ine. So you see we've changed it now to a Y to symbolize that we have a triple bond. So that would just look something like that. And so you could do propine, so on and so forth. Let's just look at a different example of 2-pentine. Right, so the pent is going to tell us that it's 5 carbons. And then the 2 combined with the I, or the Y, the ine part, tells us that there's going to be a triple bond on carbons 2 through carbon 3. So let's think about the way that's drawn. So this would have to be carbon 2 and carbon 3. But remember, with triple bonds, we have 180 degrees. So these bond angles must be 180 degrees. So this carbon would be number 1 right here, because this bond angle must be 180 degrees. And then we draw another one, again, 180 degrees. This is carbon 4. And then this one would be sp3 hybridized. So we would draw it like that. And so when you see just this drawing right here by itself, what you need to be picturing in your head is what it actually looks like, what the Lewis kind of structure looks like. So this carbon on the end is sp3 hybridized, so it's going to be tetrahedral. It's going to be bound, singly bound to a carbon, which is triply bound to another carbon, so we're linear there. And then singly bound to another carbon, where this carbon is a tetrahedral shape. And then there's another carbon down here, which is also tetrahedral shape. So you need to be able to draw this and think of this. A big part of organic chemistry is just seeing what we're talking about. All right, next up and finally, we've got Cyclo Alkanes. And so Cyclo Alkanes will be cyclic. And so they're going to form some kind of cycle or some kind of circle type looking thing. So first we have cyclopropane. Can't make a cyclic structure with only 2 carbons. And so this would just look like a triangle in the skeletal structure. But remember, that's not really what it looks like in real life. Really, you do have 3 carbons kind of in the same plane here, but they're all tetrahedral. So they've all kind of got these H's going in and out of the board. Another very popular example and found a lot in nature is cyclohexane. So the cyclo tells us it's going to kind of be like circlish or cyclic, and then the hexane tells us 6. So what you're drawing is a hexagon. And so you don't actually have to really know this point. But what you'll see if you take organic chemistry is even though we draw a hexagon, it's not actually a flat hexagon in real life. When we're picturing this, what we're actually seeing in this is this three-dimensional interpretation of what it actually looks like. So you can see it's not actually a perfect hexagon. There's varied bond angles, and it's actually free to move around in different conformers. So all I want you to know is that this is not actually a flat hexagon. So again, I expect you guys to know all of these and be able to name all of these. It's not too bad. You just have to remember the prefix: meth, eth, pro, but, pent, hex, hept, oct, non, and dec. And then you just have to know the suffix: anes for all single bonds, enes for double bonds, and then you have a number that indicates where they are, and then you need to know whether they're cis or they're trans. And then ines means triple bond, so ethyne, right, triple bonds. Make sure that you draw them as straight lines because the bond angles is 180 degrees. And then cyclo alkane, cyclo just means cyclic, and so just make like kind of like a cyclic thing depending on how many things you have. And then just know that cyclohexane is not actually a flat hexagon.